Good day, everyone. I'm Loisse Grimaldo, and I'm here to present to you about QuadPyre, fraudulent fish sensor. So, have you ever ordered something from a menu in a restaurant, for example, and you're given something that tastes different, or worse, you're given an entirely different something? Apparently, in the US, 30% of the fish food is fallaciously labeled. The menu might say it's this kind of fish, but what they're giving you is entirely different. In fact, 20 to 25 billion dollars is paid for fake seafood annually. Good thing that researchers from the University of South Florida, led by Dr. Robert Ulrich, have developed a device that can track the authenticity of seafood anywhere and anytime. It can even work even on raw or cooked fish. Within less than 45 minutes, the sensor can identify a seafood sample by classifying DNA markers peculiar to the grouper category. If the markers are traced, the fish sample shines. The goal was to design the handheld analyzer to have a small footprint and minimal power consumption, making it ideal for rapid field testing of nucleic acid targets. So, how does this work? RNA is extracted from a sample of muscle from a fish and amplified using nucleic acid based amplification. Specific primer sequences and molecular beacons were designed for the amplification and detection of target sequences in the mitochondria. The assay and hardware are simplified such that semi-skilled staff can successfully differentiate grouper from other fish in situ, such as at seafood markets, restaurants, and ships. A fluorescent label and a quenching group are attached at the two ends of the molecule. In its unbound form, the stem holds the two groups close together, causing the fluorescence of the fluorophore to be quenched by energy transfer. But when the molecular beacon encounters a target molecule having a complementary sequence to the loop, the molecular beacon hybridizes to the target molecule, moving the quencher away from the fluorophore and allowing for a fluorescent signal. The molecular beacons hybridize to single-stranded amplicons and provide an optical signal of amplification in real time, much like real-time PCR. This allows for a comparison of the signal generated from hybridization of the molecular beacon to a control sequence against the signal generated from hybridization of the molecular beacon to the fish sample to establish a ratio which is indicative of positive detection of the target fish species. The QuadPyre was developed with four modular optical reaction chambers which increase the sampling throughput of the system while maintaining portable size dimensions. The reaction chambers were comprised of high-intensity light-emitting diodes for fluorophore excitation, blue-enhanced photodiodes for emission detection, and a feedback-controlled infrared heater and detector for temperature modulation. The device is characterized by a low thermal mass design allowing for passive cooling and eliminating the need for a cooling fan. The system also yields a rapid response time for isothermal heating, which is important for reaction control, thus minimizing non-specific nucleic acid amplification and making for efficient power usage. The optical block, which is constructed of black acrylonitrile butadiene styrene plastic, or ABS, is designed such that the sample tube is placed in an open chamber allowing for unobstructed and direct heat transfer. The relatively low thermal conductivity of the ABS material and its heat capacity allow for good insulation within the chamber, thus improving heat distribution within the sample. And ultimately, the system is packaged in a 12.7 by 17.1 centimeter squared casing with a total weight of just 260 grams. The QuadPyre device outputs the integrated readings of voltages across a photodetector. That data is streamed using a standard serial connection to a personal computer where it is logged and processed by a novel set of analytical functions using Java mathematics. By utilizing Java, they have modernized the graphical interface of the QuadPyre, allowing the instrument to be controlled by either Microsoft or Apple-based operating systems. The technology in the market is being commercialized by a USF spin-off company called Pure Molecular LLC under the name GrouperCheck with trademark pending. The technology, which the team promises to make available soon at a cost of about $2,000, could have a major impact on the growing problem of seafood fraud. In the Philippines, RA number 7394, known as the Consumer Act of the Philippines, mandates that all products be properly labeled as to its accurate nature, quality, and quantity. However, it is often difficult to comply, and because of this, Many monitoring agencies are looking for innovative and safe technologies to assess species identification and authenticity testing. Assays already exist for non-seafood problematic species such as Carenia brevis or red tide causing organism, so this might have a great potential on preventing red tide disease, especially here in the Philippines. Here is the patent filed by the research group led by Dr. Robert Ulrich and their paper published. Here are my references. Again, thank you for listening. Here is QuadPyre, fraudulent fish sensor.